Welcome to Chapter 2, Unit 2, Graphs of Linear Functions. Okay, so this section we are going to learn how to graph linear functions, write the equations, determine if they're parallel or perpendicular. So this section is pretty much all about the graphs of linear functions. So the first thing we're going to talk about is a graph of linear functions. So if you want to graph something like this, there's three ways to graph this. Your first way is by plotting points. Your second way is by the y-intercept and the slope. The third way is using transformations. Now this one is usually a little difficult, and in terms of linear functions, there are better ways to do it. But it is covered. I do have to cover it. Also note that any graph of a linear function is a straight line. So that's kind of what we're looking at here. So if I was going to have, we'll do an example. So let's say we have y equals, let me think of a good one. Negative 3 divided by 4x plus 6. So we're going to be looking at several ways to do this. So the first way, plotting points, is just exactly how you would think. So we would have x equals to some number, let's say 2. Then we would have negative 3 divided by 4 times 2 plus 6, and then that would give us, we would have the 2 and that 4 cancel out to have a negative 3 over 2 plus 6. Now in order to combine this into one thing, I have to take that 6 and I'm going to have to make it a fraction with 2 on the bottom. So 6 times 2 is 12. And I would get 12 divided by 2. So that's going to give me 9 divided by 2. And what that means is we're going to have the point 2, 9 divided by 2 on our graph. And you would just continue to do that until you get, you are probably going to need, I would say, graph 3 points and connect them. So that way if you mess up on any 2, because the problem is that any 2 points will make a line. So you would never know if you have the wrong line. Since if you miscalculated one of them incorrectly, you would still always get a line. So you would need to graph 3 points and then connect them. The next one is the y-intercept and the slope. You can graph them using that. So from the equation, I can find those. Now let's say if I wasn't given an equation. So if I wasn't given an equation at all, what I would do is usually you would find the slope, maybe you're given 2 points, and you can use that and a point and that same point to build the equation, and then you can find the y-intercept from that, but you would already have the equation at that point. So remember the y-intercept, that equals b. So in our function, the y-intercept is 6. So that means the point when x equals 0, y equals 6 is on the graph. So we have our y-intercept, and the slope is, of course, it will of course be the negative 3/4. So that's the slope. Now how you would graph that is the first thing you would do is you would plot the y-intercept and then use the slope to go up, or well, go up or down by the change in y. Because remember that negative has to be associated with the top, because the change in x, we've got to keep going forward. So it would be a negative 3. So you go up or down by the change in y, and then over by the change in x. Here we would start at 0, 6 and go over. I'm going to go over first. You can go up, down, and then over, or you can go over and then up or down. I'm going to start by going over. I'm going to go over 4 and then go down 3, and that is my next point. So what I mean by that is, so say I have this, and I'm going to have 0, 6. So this is 0, 6. I'm going to go over 4, and then I'm going to go down by 3 since it's a negative 3. That's what we're going by. And then I'm going to go down by 3. So I'm going to go over 4, down 3, and this would be my next point. Of course, I would do it on a grid, so then I could just draw a line through it. Oh, not that point, through this point. This is probably a way you're familiar with doing it already. I have met a lot of students that prefer to do it this way, and that's completely fine. So the other way to do it is using transformations. Now, remember that we have f of x, let me get this in math form, we have f of x equals mx plus b. So that means we have a vertical stretch or compression by a factor of m, and we have a vertical shift by b. Note also, if we have a negative slope, that means the line has gone through a vertical reflection across the y-axis. And I will show you what I mean using Desmos. So we're going to go here. Now our function, our toolkit function that you have to transform, anybody remember this one? This is your basic linear function. It's basic, very basic. It doesn't go up or down from the origin. The slope is a constant 1. Notice that it's up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. all right through there. So whatever point you put into it, you get that point in y. So if we were going to transform something like this, let's have a look at this function. I'm going to create a new function, and I'm going to give it a slope, a different slope. I'm going to add a slider for m. I'm going to go ahead and change the boundaries of m. So I'm going to keep m between 0 and 1. Okay. And then this will show me what happens when m is a slope that is a fraction less than 1. Notice that the smaller we get, the closer we get to 0, the closer we actually get to being just the x-axis. So it's going to get flatter. The smaller the slope, the flatter it is. And now, if you change it, we're going to change it, let's change it to 40. Now notice that the larger your slope gets, the steeper it gets. And notice that it gets steeper and steeper and steeper, and it will approach the y-axis, but it will not become the y-axis. The y-axis is the function x equals 0. And that's it. So notice we get larger, it gets really steep, oh my gosh, ah, ah, ah. And that's the point here. So the smaller the slope as a fraction, the flatter it gets. The larger the slope as, a number, the steeper it gets. And remember, that includes mixed fractions. So 15 divided by 2, that's actually like a large number. Because we do include decimals here because they are real numbers. So now let's have a look at what happens for our function. So we know our slope here is negative 3 over 4. Ooh, that looks terrible. Hold on. Negative 3 divided by 4. There we go. So this is our slope. So notice, and I'm going to actually back up here. We're going to talk about that negative. So I'm going to take m, and what happens when m is, we'll say negative 40 and 0. So notice that what happens is it flips. So we would be coming from this way, right? And as we're getting smaller and closer to 0, we're getting closer and closer and closer to the x-axis. But when we go beyond 0, it's going to become flipped over. And it will get closer and closer and closer to y, but it will never happen. So now that we know that, this would be our first transformation, because we're not going to include the negative, because that's a transformation in itself. So this is transformation number 1. We have made it compressed more towards the x-axis by a factor of 3/4. So we have multiplied every y value by 3 over 4. Now let's have a look at what happens when we make that negative. It just flipped it over the y-axis, like a kind of a mirrored it over the y. And then now we're going to have that vertical shift of positive 6. And remember, because it's on the outside, it's going to go up. And this black graph represents our final function after we've gone through all of these different transformations. Okay. And that's how you would graph something using transformations. Okay, so the next thing we have is another thing that I'm going to have to go over is writing the equation, that means equation, for a function, that means, remember, that means function, from the graph of a line. So there's several really good ways to do this. One way I like to do this is just take 2 points that you can guess correctly. And what I mean by correctly is if they intersect at a whole number. So you're going to take 2 points and then you use this equation. It's the point slope. And you're going to use the point slope form of a line to find the slope intercept form. And then that would be it. Another way you could do that is you could count the rise over the run. So what that means is you would count the number it goes up to a point divided by how many over to that point. And what I mean by that is, let's say that this is 4, this is 6. Now let's say I can take a point that I know is 1, 1, and then my line sort of goes off like this, right? Well, notice what's on the line is 2, 6. X is 2, Y is 6. So I went over just 1 in my X's from 2 to 1, except I went up 5. So my slope is 5. And that's what I mean by counting the rise over the run. And then when you do that, count the rise over the run, and you get the slope. Then you can locate a point and use the formula above, or you can locate the y-intercept. And you can actually plug that directly into the slope-intercept form of equation. So that's 2 ways to do that. And that means that, let's say if I knew this intersected here, this will go here. So let's say that I know that this intersects here, and we'll say this is, my x is going to be 0 and my y is going to be, I don't know, we'll say that's -3. Then I can just do y equals my slope, x minus 3, and then that's my line. And that's how I found it from the graph, and it wasn't too bad. Now remember to find, there's another thing that for some reason they lump in with this, and it is to find the x-intercept, you set y equals to 0. So that means you need to solve 0 equals mx plus b. And then that's what you would solve. So for example, if I had, like the equation above, if we had negative 3/4 x plus 6, then we set this equation equal to 0. So we have 0 equals negative 3/4 x plus 6. And then that's what we would solve. And solve for x. I guess if we want to take that one step, no, I'll let you guys do that. That's a pretty good one. So horizontal and vertical lines. Remember, a horizontal line is a flat line straight across. That gives us f of x equals y equals c, which is just some number. And the reason I wrote f of x equals y equals c is I just wanted to remind you guys that f of x is y. So a vertical line is straight up and down. Let me fix that. So that we get x equals a. X equals some number. Now, the next thing we're going to come across is determining when, determining when lines are parallel or perpendicular. And parallel, remember, is when they will never touch, and perpendicular is when they intersect at 90 degrees. Let me insert a degree thing. Usually that's the shortcut for degrees. So 90 degrees. And it has to be at a right angle, or else it's not technically perpendicular. I mean, it's intersecting, but it's not perpendicular. So one thing to make note of here is if we're talking about parallel lines, we're talking about, lines that don't intersect. They don't intersect ever. So what does that mean? So that means that they should probably, if they're never going to intersect, they're going to have, I guess, the same tilt, if you could see it that way. Right? Because let's say I have a line. Unless I have another line with the exact same tilt, it's going to eventually intersect. Like, let's say I have a line that has slightly less tilt. Oh, do you see how they eventually will intersect? So therefore, if those tiltinesses have to be equal, then those tiltinesses are the equivalent of our slope. So the slopes of parallel lines are equal. They only differ by the y-intercept. And we can go ahead and I'll head over to Desmos and show you that. So this guy, we'll get rid of these guys. So we're going to have, we'll do we'll do the one that we've been working with, negative 3/4 x plus 6. Oh, way off. Right, there's our line. The line we are familiar with, the line we love. So here's our line. Now I am going to make another line that has the same slope. Actually, I'm going to make, a line that has the same slope. So they're parallel. Yeah. Now I'm going to add the intercept and I'm going to show you. Let's make this one a different color. What color do we want? Do purple. So I'm going to show you. Here I'm only changing the x-intercept. The y-intercept. And notice that it is always staying parallel to my line. So in order to build a parallel line, you really only need the slope. You can just make up whatever intercept. Here, I'll make that y-intercept. Any y-intercept you want. Okay, so now let's talk about perpendicular lines. They must intersect at a right angle. Now, what that means, and there's really no way I could really explain this to you because it goes through like a lot of geometry, and that's not the scope of this class. The book goes over it, but I'm not going to. So perpendicular lines must intersect at a right angle. So what we're going to do here is we're going to define a negative reciprocal. And that is the value that when multiplied by our original value, we get a -1. So that means if our original value is 3, then -1/3 is our negative reciprocal. And that is because -1/3 times 3 equals -1. Sorry about that. So that's what a negative reciprocal is. If you have -2/3, and it goes the other way too, then the negative reciprocal is 3/2. Get rid of that there. All right, let's go down, back down. Sorry, it keeps jumping like that. If you have -2/3, then the negative reciprocal is 3/2. And that is because notice that -2/3 times 3/2 equals -1. So I'm going to show you guys something about perpendicular lines. Let's head back over to Desmos, back where we were. So if I wanted to make a perpendicular line to my line, it would have to be the negative reciprocal slope. And if we have -3/4 already, then the negative reciprocal of that is going to be positive, and it's going to be positive 4/3. So notice also, just like our parallel line, that the only thing that's going to really be up to us is going to be the y-intercept. So, of course, just like the parallel lines, so that means, let me put it right here, just like parallel lines, you can make up whatever y-intercept you want, and as long as the slope is the negative reciprocal, your line will be perpendicular to your original line. And that means that if you were given an equation of a line and you were saying, hey, give me a perpendicular line to this line, then you would just get the negative reciprocal slope and you could attach whatever you want as a y-intercept. Now here is another one. If you are given a point that must be on the perpendicular line, then you will use the formula, the point slope form, equals mx minus x sub 1. You will use this to find the slope-intercept form of the line. So that means that if I give you a line, you know, like x plus 1 or whatever, and I tell you I want a perpendicular line that goes through a different point, then you're going to take the negative reciprocal slope of your original function and you're going to use that as m, and you're going to take the point I give you and plug it in as x and y, if that makes any sense. Let me see if maybe I can illustrate that better. So if I give you 2x plus 3 equals y, and I want a perpendicular line, which is what this symbol means. I want a perpendicular line through the point, I don't know, 7, 1 or something. Okay, now another thing that we're going to discuss is, let me get my typing tool. We are going to discuss solving a system of linear equations. So systems of linear equations. And what those are about is, I believe in this chapter you only do 2, so for now it will be 2 linear equations. And when we say to solve them, what we mean is to find where they intersect. The intersection is a point that will satisfy
waking up. I'm gonna get his bottle. He's gonna be hard.
Both lines. God, we cannot just like